Hey everyone, welcome to the first CS 128 honors lecture for this fall semester. Today will be a short introduction to Rust and how to get everything set up on your computer. So our goals for today are as follows. First, we'll go over some course logistics to give you a better idea of what to expect from this course weekly. Next, we'll go over a very short overview of what Rust is and why someone might want to use Rust. Then we'll focus on getting Rust set up on your computers. And finally, we'll walk through the anatomy of a simple Rust project and have you compile and run your very first Hello World program. So first off, some course logistics. Lectures will be releasing every Monday and Wednesday. They'll be posted here on YouTube, and we'll also make announcements about them on the Discord server. Homeworks and NPs will also be released Mondays and Wednesdays. Homeworks will be released every week, while NPs will be released every other week. And finally, our office hour schedule should hopefully come out very soon, possibly within the next day or so. Okay, great. So let's get into it. So what is the Rust programming language? Well, Rust is a multi-paradigm systems programming language that places emphasis on safety and performance. So what does any of that mean? Well, let's break it down. When you hear multi-paradigm, it is referring to the different programming paradigms. You've probably come across these before, whether it be in CS 124 or 128 or any other introductory CS course. The programming paradigms categorize languages based on their features. There are many different paradigms to fulfill every demand necessary. Most of you will have experience with object-oriented programming if you've taken CS 124 or if you've learned languages like Java in the past. So a multi-paradigm language, as the name implies, is a language that supports several different paradigms. It has features that are found across many of these paradigms. Rust is primarily an imperative language. However, it supports functional programming features, so it's classified as a multi-paradigm language. In this class, we'll be teaching you most of Rust through the lens of object-oriented programming. However, at the end of the semester, we will briefly talk about some functional programming. So what is systems programming? Well, systems programming is a branch of CS involved in developing core system software that provides services to other software applications. This involves things such as operating system kernels, like the Linux kernel, or device drivers, like those for GPUs or CPUs. These programs are the foundation of all application software. So they are very performance constrained and need to operate efficiently and effectively. Therefore, since you can make these programs in Rust, it's safe to say that Rust can be used for any application where systems resources like memory and CPU time are a concern. For example, in game development or when creating game engines, this is something Rust might excel at since performance is of high importance in game development. Okay, so as I mentioned in the previous slide, Rust places a lot of emphasis on performance. However, it does so while also being incredibly memory safe. Rust enforces strict rules at compile time to ensure memory safety, all without the need of a garbage collector. How Rust does this exactly is something we'll get into in a later lecture, but all you need to know now is that these rules and the lack of a garbage collector allows Rust to be extremely efficient by eliminating significant runtime overhead and also while avoiding common bugs like null pointer dereferencing that are found in manual memory management languages like C. Okay, so now let's hopefully get Rust set up on your computers. I've included a couple links in the description to the installation guides for Rust. If you're on Mac or Linux, you're lucky. It's as simple as running this command. For Windows users, you'll have to download this executable file that can be found in the installation guide. Again, I recommend you head over to the docs and follow the instructions there. Once you've followed the instructions in the docs, you should try running these commands, cargo-v and rust c -- version. If you get similar outputs to what's on the screen, then everything is good to go. I encourage you to pause the video right now and come back whenever you've successfully installed Rust and can execute these commands. If you need any help getting everything set up, feel free to message us in the Discord server. Also, we'll hopefully have some office hour sessions too before the first homework assignment is released. So maybe you can stop by then if you need some help. Okay, great. So now I'm assuming you have Rust installed and you're ready to go. But before we dive into creating your first project, let's talk about one of the tools you installed alongside Rust. As you might have seen in the previous slide, you installed something called Cargo. Cargo is Rust's build system and package manager. You can interact with it through the command line, and it handles tasks such as interacting with the Rust compiler and downloading and building libraries your project depends on. As a package manager, it functions very similarly to pip, gem, or npm, which you might be familiar with if you've ever used Python, Ruby, or JavaScript. Okay, at long last, we can finally get into setting up and running a Rust project. So we've transitioned over to VS Code. Before I get started, I want to mention that you're allowed to use any IDE or code editor for this course, but I do recommend using VS Code or some fork of it, since there are some great Rust extensions in VS Code that make developing in Rust a lot easier. I'll include links to all of these in the description. Okay, so let's get started. So as we know, we have a tool called Cargo, which we can use to build Rust projects. So in our terminal, we can do cargo new lecture 1. Cargo new is the command to create new Rust projects, and lecture 1 will be the name of this project that we create. So if we hit enter, we can see that a new folder has been created. Inside of this folder, we have another folder called source, a .getignore file, and also a cargo.toml file. The cargo.toml file is a manifest file that contains metadata that is needed to compile the project. If you've ever used JavaScript or Node, you might see similarities between this file and the package.json file. However, the details of this file will be covered in a future lecture. So for now, we can move on to the Rust files. So if we navigate over to the source folder, you will see we have a file called main.rs. This is our Rust file. All Rust files will end with the .rs extension. So if we click it, we can see what's inside. Inside of the main.rs file, we have a single function called main. The main function is very special. Every Rust program will have it, and it always is the first piece of code that runs in an executable Rust program. So inside of our main function, we see that we have one function that will print text to the terminal, specifically hello world. So let's try compiling and running that. So there are a couple ways to do that. One would be to use the Rust compiler directly, rustc. So let's try doing that first. So let's navigate over to the lecture folder. And then within this folder, we can run the rustc command, and then we can pass the path to the main.rs file. So let's run it. Okay, great. So this is compiled and it has outputted a binary executable for us, which we can then run by simply typing the name of this file, the /main, and we can see that hello world has been printed. And congratulations, you've just run your first Rust program. This process of compiling an executable and then running it is very similar to what you'll be doing in CS 128 with C++ and Clang. However, in Rust, while compiling with rustc for smaller projects is fine, as your projects get bigger and bigger, and you start to include dependencies, you'll want better tools to manage your project. So this is where cargo comes in. As we learned, cargo can directly and safely interact with the Rust compiler for us. So instead of using the Rust C command, we can actually just use a command called cargo run. So let's try that. Okay, as we can see, the cargo run command both compiled and ran the executable for us, which is very convenient. No need to use two commands. Cargo also comes with a bunch of other commands, one being cargo check. Cargo check is a great tool that you can use to quickly check to see if your code will compile without having to build an executable. So we can do cargo check, and it didn't give us any errors, so we know that there are no syntax errors within our program. Cargo check is often much faster than running cargo run, so it's a nice tool to use periodically to see if your program will compile. Like I mentioned, cargo has many more great features that you probably won't need to use for this course, but I encourage you to check it out in the documentation if you're interested. Okay, awesome. That's it for lecture 1. It was a short one. You can usually expect lectures to be around 25 to 30 minutes, but hopefully this was a nice and easy introduction to Rust and the course. Thank you so much for listening, and I'll see you all next week.